What is up, y'all? This is Coach Jay, and you are at my house right now. Congratulations. I hope you are having a great night tonight. We are at Algebra 3 review, P1 to P5. Yes. Hope you're excited too. If you're just excited right now, I want you to yell out a scream. Let's go. I hear you all the way from Sweden. All those that are in Sweden right there, hope you're having a fantastic night. We are going to get started with some review. The only problem is I kind of forgot my my stylus for my pen on here, so it becomes a little harder. Good news though, I have some whiteboards behind me or some glass boards behind me. If for some reason you are unable to see this, please make sure you let me know. We're going to do the best we can though with what we are given. We're going to have a 30-minute little podcast here, and we'll get after it. All right, we'll get after it today. All right, so as we get started, if you have questions, go ahead and throw them out there. I am going to also pull up right here the review for myself. And that way I have it right next to me here. So if you throw out a number, I'll be glad to go ahead and do that and be able to get that done there and kind of rock and roll, okay? So let's do this. Let's go. Let me go to my remind. I saw some questions there. You can either throw it through text or remind 101. It's completely up to you there. But once I see it, I'll be able to do it, and we will rock and roll off that. So let me get these questions on this side. All right. Quick question was from got some questions out there. Yes, we will be. We'll be watching. We'll be using the time in class tomorrow to review as well. So if you, for some reason, are unable to make it tonight, feel free to come tomorrow to class, and we'll review there as well. Okay. I'd like to do this. I'd like to start off by just kind of saying number 33, the y cubed minus 8 is not on the test. Any cubic stuff we haven't put on the test. We won't put on the test there. So no worries there. Again, no 33 on there, okay? So let's start with the factoring. I know there's a lot of questions on that. So let's start by doing the first one. So let's do 15, x to the third. I'm hoping this looks good here. Let me make sure. I'm hoping that looks good. I'll try to really make sure I put it big. Plus 3x squared, okay? Now, as I approach this, one of the main components of this is to remind yourself that kind of we have some steps here, right? So the first thing I want to do is always look at GCF, right? That's very important to know that, okay, I got to look at GCF. The second thing is to know whether it's either 4, 3, or 2 terms, right? So that's very important to be able to identify how many terms there are, because if there's like 4, we know that we're going to end up grouping. If there's 3, we'll factor by saying with 2 that multiply that equal the last, add b equal the middle. We'll look at that. And then also the 2 terms, we don't have a cubic, so it's going to be probably a difference of 2 squared, so knowing that it's a plus and a minus there. So that's kind of where we're at. So in this one, let's look and see, is there a GCF? And I think there actually is. The GCF is something that is in common, that's shared between both of these. And it would actually be a 3, so we're going to pull a 3 out. And then also we have x to the power of 2 that's shared. You see this is the lowest one, so we're going to put squared right there. So once I do that, I ask the question, is there anything of the first part that's left over? So I'm not done with GCF quite yet. I have to ask myself, is there anything left over? And I look and see that, well, what times 3 equals 15? And it would actually be 5, okay? So we'll put 5 there. And then also if x squared's here, what times x squared gets me x to the third? And that would be x there, okay? So we'll have 5x on that. And so that's check 1, okay? We've done the first one. Now the second one, we notice that we've already used a 3 and we've already used the x squared. Well, we don't just leave it blank, or we don't put 0. So we actually just say the value of 1, okay? So actually that right there would be my answer. And then I look and see, well, difference of 2 squares, because this has 2 terms, but there's no minus in the middle. I can't take the square root of both. So actually that would be my complete answer for number 8 there, okay? And again, I just want to make sure we go through each part of that. So again, if you have more questions on this factoring stuff, let me know. I've got my again, I've got all my phone and stuff up, so it'll come straight up on there. So let me know on that. All right, perfect. Let's go to the next one. I'm gonna keep going with factoring stuff because we'll hit on some of maybe the higher stuff tomorrow, unless I'm asked about it today, which in that case I'll be more than happy to do it. The next one is x squared minus 11x plus 28. Okay. Now in this example, we know that first thing is GCF, and we notice that there's nothing between these three that I can take out, and so I have to think to myself, okay, if that's the case, I can't take anything out from there. What I know there's three terms, so we know that we're going to kind of break it up. And since a is equal to 1, remember a is the first value over there, okay? Since a is like this imaginary 1 right there on that side, we know we could just do it the basic way, where we simply multiply two numbers together that equal 28, but when added equal negative 11. We can just start with x in both of these, okay? So I'm just going to put 28 down below, and you might have to do this too, although some of you may just be might just get it pretty quickly to where you kind of get it and understand it. So you just kind of find different values that make 28. So 1 and 28, 2 and 14. 3 doesn't really go into that, so we look maybe to 4 and 7 and so on and so forth. And we also know that we have the negatives of those values too, because negative times negative is a positive. So we think about what two, when added together, get me to 11, but specifically negative 11. We know 4 and 7 make 11, but we know we have to get to negative. So we're going to say that it'll end up being negative 7, negative 4. And what we could do is, just in case, I was talking to Nicole this morning, remember that you could also distribute this to then also figure out whether it really does come back to here. So what's nice about all these is you can multiply or distribute these to really make sure that it's true, that it does equal there. All right, so just a heads up on that. Going forward, okay? All right, fantastic. So let's do this too. Let's go to the next one. Oh yeah, this is good. Number 30. All right, let's hit this one. This one is a 4-term one, so we have like x to the third, right? And minus 3x squared minus 9x plus 27, okay? So we've got this kind of set up in this way. We first think, is there anything that is shared between all 4 of these, okay? Well, even though there's maybe an x between these 3, remember it's got to be all 4, and really there's not. So we go straight to the next thing, which we remember with 4 terms, we go straight to grouping, okay? We at least try it. So in grouping, we group the first 2 and the last 2 together. So we're actually breaking this up. So the question is out of the first 2, what is the GCF, or what is shared between those 2? And we know that we could actually take out an x squared, leaving us, this is kind of where we have leftover, right? We're leaving us, we took x squared out, we're left with x here and a minus 3 here, okay? So we put minus 3 on that side, erase that. So since we have the x minus 3 there, we then go to the next one, and I look and see, okay, so what can I take out of each of these? Well, I can notice that each of these could be divided by 9. So in this example, I'm going to take out a 9. Well, since this first value is negative, I'm going to take out actually a negative 9 and just see what happens. So if I took out a negative 9 here, okay, what's left over? Well, we're left with an x here. And over here, well, this is the confusing part. Normally we drop the sign, but because I took out a negative 9, 27 divided by negative 9 is actually negative 3. Remember that in order to do this, we've got to make sure that both of those are the same in order to group, because I have to, in this first part and second part, what is shared? Well, what's shared is x minus 3. And what's left over? Well, you have x squared minus 9, right? So I'll leave that as is right there on that side. So you'll see, again, just like before, this in this first one and in the second one, the x minus 3 is shared, so that's why we drop it, leaving us with x squared minus 9. Well, one thing you've got to always check is to make sure you're done. Remember, with x squared minus 9, what we want to do on this is we could see, well, there's 2 terms with a minus in the middle, so we can actually take this and see, can I factor that further? Well, I could take the square root of both, right? And with a minus in the middle, that means that ultimately we could go x and x, because the square root of x squared is x. Square root of 9 is 3. And so we'll have x plus 3 at x minus 3. Now, if that was plus 9, I couldn't do that. I would leave it as is. But because of the fact that it's negative, I can actually take that one step further to right there. Okay? Awesome. Again, I haven't seen many questions here. So if you do have any questions, let me know. I know as I look at it, I do have some viewers on there, which tells me that some people are watching. Feel free to text in to my number, or even throw down an email of some kind, or through Remind 101. I'll go straight to my phone. So feel free to do that. All right. Hopefully this factoring stuff's helping. Now, I think it's 31 we're going to look at, and then we'll look at 32. So we've hit all of the factoring ones there. The one that with this one is x to the 4th minus 16. Now, the same thing holds true. We look and see, is there anything that I could take out of both as a GCF? Well, really, there's not, right? I can't take out anything from both. But what I notice is that there's two terms with a minus in the middle, okay? Now we're cooking like flipping bacon on a griddle, okay? That should be a lyric, I tell you what. I'm sorry. Ooh, sorry, I didn't know the camera was right there. I'm getting a mint right there. Sorry. So as we go, we have two terms with a minus in the middle. And so what we're going to do is we're going to try to take the square root of both of these. So the square root of x to the 4th right here would actually end up being x squared. So that's where we put in for both. Because there's a minus in the middle, we'll have a plus and a minus here. And then the square root of 16 would be 4. Now this is where that one statement that I talked about comes into play, because anytime I have a binomial like that, two terms, that's a binomial. When I have that there, and I'll do 18 and 23 for sure. I'll come back to those, y'all. X squared plus 4, I can't factor with that plus in the middle. So I'm actually going to keep this as is. But the x squared minus 4, that's a different story, okay? So I can actually figure that one out and simplify. Sorry, I'm going to keep that there. By factoring that out one more step further, hopefully you can see that on this side, to where I take the square root of x squared as x, and square root of 4 is 2. And then I'll be left with x plus 2, x minus 2, and x squared plus 4, okay? Hey, I hope you all can see that clearly. I think so. Perfect. I just want to make sure you can see it clear on that. But that's, again, how you would do number 31, okay? Awesome. All right, the next one, okay, hopefully, again, you got that down. Before I go to those two, 23 and 18, let's look at number 32. Put this down. Okay. Now, this right here is one of the tougher problems, okay? Just as one of the tougher problems. Now, first question, do I have a GCF? The answer is no. So we go straight to how many terms there are. In this case, there's 3, right? 3 terms. And we know if A is not equal to 1, meaning this A is greater, it's greater than 1, okay? So what I've got to do now is I've got to come back kind of to these and note that you can do check and guess, by the way. Okay, if you do check and guess, you're absolutely fine, okay? Absolutely fine. However, A times C is what I'm going to use, because I know the answer is always going to be right. So remember, this is A, B, and C. Remember, the sign goes with it, right? -1 and -2. So I'm going to multiply A times C to get -30. Okay, so 15 times -2 is -30. And so what I'm going to do is I'm going to separate these just like I did with when A is 1, except this time I'm going to put 15x in for both the beginnings there. So the question now becomes, two numbers when multiplied that equal -30, which is the A times C value, but added equal -1. Now you can again come down and put the different values. Like you could put that 30 and -1 was 1, and 15 and -2, and vice versa, right? So the negatives can be opposite. You also could know 6 and -5. You could keep doing that, right? But as you notice, you probably could figure this out in your head here. For some of you, would actually be -6 and +5. So we're going to put -6 in for here, +5 in for there. Now the next question is, what can I take out of each? Well, let's see here. Can I take anything out of 15x plus 5? Is there anything shared there? And I think I could actually take out a 5, right? I could take out a 5. And when I do that, 5 goes into 15 3 times. 5 goes into 5 one time. Okay. Then I look here and say what number goes in for both here. Well, I could go 3 in, right? 3 goes into 15 5 times. And 3 goes into 6 2 times. Now with these GCFs, or the numbers that kind of go into both here, I'm going to drop those two. And I'm going to be left with those two factors right there. Okay. That's how you would approach that there. Now I'll tell you, there are going to be 2 of these. Okay. There'll be 2 of these. All right. So it's very, very important that you know how to do this here. Remind me tomorrow and I'll give you some different ones. Maybe we could kind of go through them together. But again, this is very important, how to do A times C method there. Okay. Or check and guess. If you do choose check and guess, that's absolutely fine. All right. Since we're going backwards, we're going to continue. I'm going to go to number 23, and then I'll go to 18 on that one. All right. So let's check this one out. This one's another good one. Okay. So I've got 23. Make sure. Just got another question here. And I'm going to come back. I've got them over here on my right board, 23 and 18. Got them on that side. I'll remember to do that. Why did I pull out a 15x at the beginning? Okay, so great question. So when we do the 15x, when we do the a is greater than 1, right? So like remember, it's 15x squared dot dot dot. When a is greater than 1 with that trinomial or 3 terms, right? The way that I do it is I put the 15x in first, and I use the A times C method, and then I'll end up taking stuff out. At the end, it will work out. The big thing that people get confused with is they wonder, Coach, hold on, I can't do that. And in some regards, you're right. Now, in the sense that if you were to do check and guess method, you would never start with 15x. But what I'm trying to do here is trying to have a cut and dry way to teach it or to do it. And this right here allows me to do that, to where when I find these 2 values, which was like -6 and +5, I then can say, what value can I take out of between 15 and 6, and what value can I take out of 15 and 5? When I reduce that, that will end up getting me with the correct factors that are there. I hope that makes sense. If it doesn't, tomorrow we're going to do a couple more. I will tell you, this right here is probably one of the tougher things on the test, for sure. Probably one of the tougher things on the test for sure. So that's one thing that I'll hit on again, is probably give a couple more types of problems that are similar to that. Maddie, I hope that helped there. I really do. I hope that helped. All right. So what we have now is 15x to the 3/4 and 5x to the 1/2. Okay. All right. So what we have is this right here. Now, when we simplify this, a lot of times people look at this like, man, this is really awful. This is really bad. Well, it looks bad, but it's not too much. Let's start with the coefficients, because that's what we always start with. So let's start with 15 divided by 5. And we know in that situation we'd end up getting 3, right? So we're just going to put 3 right there. Now, let's keep x to the 3/4 up on top. The only difference now is I want to take this x to the 1/2, and I want to bring it to the top. Remember, we can do that as long as we change the sign, right? So as long as I change the signs of it, I can change it from top to bottom as long as I change the sign of my exponent. Not the sign of what's out here, but the sign of my exponent, okay? So when I bring it to the top, it'll end up being x to the -1/2, okay? Now just a side note, okay? Just a side note here, and I'll erase this here in a second. If I had x squared times x to the 3rd, this is side note here. Remember that I have to add those 2 together, right, to get x to the 5th. Unlike if I had a power to a power where we multiply, right? Now, up here, that's important because that means I'm going to add these 2 together right here. And in order to add them together, I have to have common denominators, right? Common denominators. So if this has a 4 here, I want to make sure this one matches. So I'm going to change the bottom to 4, which means I'm multiplying the bottom by 2. And that means I'm going to multiply the top by 2, right? To get -2 fourths. So if I have x to the 3 fourths times x to the -2 fourths, that ends up being x to the 1/4, right? That means I've got 3x to the 1/4 power. And that's how I get my answer. And again, remember, common denominators in this situation. Now, sometimes if I just had, you know, just a whole number on top and bottom, very similar to, I'm trying to find a good one that would be very similar to like number 11, where you have ones on top and bottom that are like whole numbers. You don't have to worry like about common denominators there. Just when you have the fractions there, that's when you worry about it. Again, same principles, maybe just a little different from what we've seen before, okay? I hope that was helpful for y'all. Again, question me. If you have any other questions on that, let me know, okay? I will come back to it just like I did on the previous one if you have another question on that one, okay? Yeah, Caitlin, if you have, I would guess probably 1 on the test, no more than 1, if 1. Tomorrow, I could trying to remember if it was or not. I think there might be 1 on the test. Here's the deal: the principles of those are going to be all over, right? So like number 11, you'll have 1 very, very similar to number 11, very similar. So you might want to just kind of check that one out. You know what I mean? Yeah. So those concepts, though, one like number 9 will be important. So again, that's what I would do if I were you on that one. Okay. So yeah, we could do another one like that tomorrow on the test before the test or on the review. But again, I would just make sure, again, bring it to the top and then kind of go off that. Okay. Awesome. All righty. Let's do number 18. All right. So number 18 is square root of 7 divided by square root of 3. Now this is unlike number 16 in the sense that 16 you can actually divide that out, right? So let's do this actually. Let me do 16. So if we had the square root of 24 x to the 3rd, right? Okay, this is 16 by the way, just heads up. Over square root of 3x. Since it both are underneath the radical, I could divide this out, right? So I do it by the coefficients first, like I did in the last problem. 24 divided by 3 gets me 8. So we have the square root of 8. And x to the 3rd over x, if I brought, like again, these are 3x's, right? If I subtracted them, 3 minus 1, or if I brought it to the top, changed the sign, the reality is I would have x squared here, right? So I divided there, then I can simplify this square root, you know, and this would be 2 and 4, right? This would be 2 and 2. Pair of 2's brings it to the outside, and the square root of x squared is x. So I'd have 2x on the outside. Left in would be this 2 because it doesn't have a pair. So it'd be 2x square root of 2. Now, that's just an example of one where you can divide it out. This one right here, square root of 7 divided by square root of 3, is one I cannot. That's the problem, is I'm unable to divide 7 divided by 3. So in order to keep going forward, I'm going to get rid of this square root because we don't like square roots in the bottom. So we're going to multiply the top and bottom by square root of 3. Okay. Now, as I do that, I then look to the top and say, well, what's the square root of 3 times square root of 7? It's actually going to be the square root of 21. Okay. What's the square root of 3 times square root of 3? That's going to be the square root of 9. What is the square root of 9? Say it. Say it out loud for everybody to hear. Just like Dora the Explorer. Very good. 3. And so actually that would be my answer. Remember, I can't divide these two together. One's inside the square root, one's outside. I can't. Now, if there was a number out here with no plus in between, in that situation, I could divide here and here. But I cannot divide inside a square root, inside a root, and outside of a root. So that's just a heads up there. So that's actually what I would do. Remember, 21 actually doesn't have pairs because 3 times 7 is 21. no pairs there, so we'll leave it as the square root of 21. I cannot simplify. Okay? Excellent. All right, do y'all have any other questions at all out there? Let's say you had another one you want me to go over or whatnot. Feel free to do that. Number 11 is a really good one. I feel like I need to do number 11. It's a good one. All right, let's do number 11. All right, negative 27. X to the third, y to the negative fifth. No, this whole thing's going to be the negative second. Okay. And again, there's kind of a couple ways you could do this. I'm going to do it this one way just because I feel like it does become a little easier. So how I approach this is I'd like to just simplify the inside first and then do this second. This is second, and I like to go that first, okay? So like 29 or 27 divided by 9 with two negatives, we know will be 3, right? So we're going to keep 3 right on the top there. Then I look and see, okay, if there's x to the third and then a negative 4 right here, if I brought that negative 4 to the top, I changed the sign, same for this y to the negative second. So really what I would have is x to the third, x to the fourth, because I changed the sign, y to the negative fifth, and y to the second. Again, I changed all of those signs there when I brought them to the top, okay? If you can look at this and actually subtract it, go ahead and do that. You don't have to do it the long way like I'm doing. But I want to make sure I don't assume, okay? Now the next thing I'm going to do is I'm going to combine. So x to the third times x to the fourth, that's x to the seventh. Y to the negative fifth times y squared would be y to the negative third, okay? And now I'm going to take that and I'm going to make that to the negative second power, okay? Negative second power. So then I'm going to distribute this. This is actually going to go to each one of these 3, right? So a couple of things first. 3 to the negative second is one that a lot of people struggle on. I want to actually see. Hopefully you're seeing this there. There we go. Okay, I can actually do this right here. Yeah, right here. Okay, so if I have 3 to the negative second, right? Remember the 3-line rule, or what we can do is say, okay, if I want to make this positive, I'm going to put it to the bottom. So this is what's the same thing as this. It's actually going to be 1 over 3 squared because I got to make that positive by putting it to the bottom. We know 3 squared is 9, so 1 over 9 is actually my answer there. So this right here, this 3 is going to be actually 1 over 9. Okay, so I'm going to actually erase this. It's going to be 1 over 9. Okay. X to the 7th stays on the top, so we're just going to keep that. I'm going to put this as a fraction here. So 9's on the bottom, x to the 7th's on the top, and 7 times negative 2 is actually negative 14. So we're going to put that there. Okay, so I've got that one done. All right, negative 3 times negative 2 is 6. I'm going to put 6 here. Y to the 6. Since this is positive, we keep it there. And the negative 14 will change to positive by putting it to the bottom. So that's how the negative 2 is applied. So my answer would be y to the 6 over 9x to the 14. And that's how I would get that answer for that value there. Okay. Awesome. Okay. Y'all are getting some good questions in right now. I know I was supposed to do 9:30 here, but I'm doing a little overtime because I'm here to help y'all. I really am. I'm here to help y'all. Number 6 was probably one of the most missed problems on the quiz. Probably one of the easier problems, but I can see how people get tripped up because we forget to follow PEMDAS. PEMDAS will guide you. Okay. All right. So let's do this. Let's go. Let's do this thing. So 8 minus 2. Let's see our bracket. 3 minus 5x minus 11 or minus 1. There. Okay. So remember, PEMDAS tells me that we are going to go parentheses first. And since I can't simplify anything inside, I'm going to leave that as is. So then I work outside. So then I go in this bracket here. And I notice this negative is kind of butting up to this parenthesis, which means that it's got to be distributed to each. So which means that down below, we're left with 3 minus 5x. It's got to go to both, right? It's got to, remember, it's got to distribute, plus 1. That's important, okay? That's important. So it's got to be minus 5x plus 1, all right? Now, once we distribute that, we drop the parenthesis there. So now what we can do is just kind of work inside to where we know 3 plus 1 will get me 4. So we're going to go 4 minus 5x with this negative 2 out here and there. Now, one other thing people like to do is once they kind of figure this out in here, they like to subtract right there, but we cannot do that, okay? Cannot, because the next part is we've got to multiply. So we can't add and subtract until we multiply. So because this is butting up to this bracket here, the negative 2 is going to go to the 4 and the negative 5x. So we should have this. 8, it's going to be negative 8, because 2 times 4 is negative 8. Negative 2 times negative 5x is 10x. And what we got now is 8 minus 8's gone like a freight train, gone like yesterday. And now we're left with 10x. That would be my answer. Okay, so just be careful. Make sure that's distributed to each, and then the negative 2 is distributed prior to subtracting or adding. Okay? Awesome. Awesome, awesome, awesome. Okay. If you have any more questions, let me know. Here's what I'd like to do here. Before I get to the next one, I'm going to do this. Just want to kind of walk through a couple of things here. Okay. All right. So as you can see here, a couple of just little details that I want to go over. This number 1, I canceled out. I deleted. So you can delete that too. Hopefully you have. And we'll look at actually this one right here. Number 2, just kind of a heads up. It says, yeah, just make sure you read the instructions. These are not meant to be hard. It's more just plugging in and chugging, but just be careful of that. As far as distance goes, remember distance is one value minus the other, and then you could take the absolute value of that to get what the total distance is between the two numbers. So negative 17 minus 4 is negative 21. Absolute value is 21. Remember, distance is always positive. Also, number 4, make sure on 4 you distribute 5 first prior to adding or subtracting. And once I distribute 5 here, we can add and subtract like terms, okay? Same with 5, make sure the negatives distributed to both the 7y and 2, and the 3's distributed to 4y and negative 5. Once I get there, I can simplify by adding and subtracting like terms to get it there. As far as evaluating, make sure x equals 4, knowing how to plug in. If you have an exponent to an exponent, knowing what to do there. Remember, negative 2 to the 3rd does not go on the bottom. Let me repeat that. Negative 2 to the 3rd does not go on the bottom. Only when the exponent is negative do I reflect something towards the bottom. So just a heads up on that one. Okay. Remember scientific notation. Remember the third root. Third root means that we have groups of 3. So like x to the 7th, we have 2 groups of 3. So we have x squared to the outside. Y to the 12th has 4 groups of 3. So we have y to the 4th on the outside. So just a heads up here. Remember, this is square root, and you'll be good to go. G to G on that. Remember when we simplify in numbers 19 and 30, or 19 and 20, make sure you multiply by the conjugate. In this case, square or 3 minus square root of 7. And over here, square root of 3 plus 1. 21 and 22, we looked at today in class. We can do another one of those. And then also 24 through 27, remembering to distribute on 25, 26, and 27. And then number 24, making sure you distribute the negative and then add, subtract like terms. Remember the same exponent. You must have the same exponent in order to add and subtract the like terms there. Okay? Hey, I hope this was helpful for you. I know that it has been, well, I know there's been a lot of information. I completely get that there. And again, if I can be of help in any way, please let me know there, and we'll go from there. Tomorrow we'll have all day in class to work, so be careful, be ready to go on that, and we'll rock and roll. Okay? See if I can make this. Oh, that was bad. That came straight down. I thought I was gonna hit it. Have a fantastic day. See y'all later. Love y'all. Bye. Bye.